Welcome, ladies and gentlemen. So what I'd like to do is show you how to solve two-step equations. Now, previously, if you watched the one-step equations, basically all we were looking at doing was identifying the variable that we're solving for, which again, we're only dealing with one variable in this case, so that's pretty easy. Then what we're doing is identifying the operations. Now, for one-step equations, it was pretty simple because there's only one operation that's happening to your variable. Add, subtract, multiply, divide. Done, right? So, but when dealing with two-step equations, we now have two operations. So not only do we have to undo two operations, we also have to follow some rules. And the rules are what we call the reverse order of operations. So just like when we were simplifying an equation, we always use the order of operations, right? You know, PEMDAS, a lot of times people remember them by. Now, when we're solving an equation, we're actually going to go in the opposite order. We're actually going to do the reverse of that. So when we're undoing operations that are happening to the variable, we always want to undo addition and subtraction first. Then we want to undo multiplication and division. Now, addition and subtraction, well, that's only going to be one operation. We're only doing two. So first thing we want to do is look at our equations and understand at least what variable we're trying to solve, or at least what variable we're trying to isolate. Then what we're going to do is we need to identify what operations are happening to the variable that we need to undo. And then we just follow the reverse order of operations. So let's look at example number one. Example number one, you can see that x is our only variable, right? You can also see the operations that are happening to x. It's being multiplied by 3, and it's being subtracted by 4. So we need to undo multiplication, and we need to undo subtraction. But we got to follow them in order. So again, as I said, you always undo addition and subtraction first. So you can see we're going to undo our subtraction by adding a 4 to both sides. Now remember, just like one-step equation, we have to, whatever we do on one side, we have to do on the other side, which is the properties of equality, right? So therefore, I now end up with 3x. That becomes a 0, which we're not going to write, equals 24. Now you can see, now by undoing that first operation, I've now created now just a one-step equation, where now my variable is being multiplied by 3. So to undo multiplying by 3, I divide by 3. That's going to go to 1, so that's going to leave me with x equals 8 is my final answer. All right, this one can be pretty confusing here. And I'm kind of surprised actually I put this one up next, because a lot of students will get quickly confused on this. Now, if you remember in one-step equations, one of the tips I wrote was always write your variable to the farthest left. Once you get used to solving equations, you can kind of bypass that. You know, for me now, I could solve this without doing that. But as you're getting used to solving this, always write your variable to the far left. So if I was going to rearrange these, mean my variable to the left of 5, the variable is negative. That's a negative x. But my 5, that's a positive. There's no negative in front of the positive. So that's really a positive 5. So now you can see that the 5 is actually being added to my x, which becomes very confusing because students will see the negative and say, oh, we're subtracting 5. No. The sign in front of 5 is what's telling you if you're adding or subtracting. So by rearranging them, you can see now my 5 is being added to my x. So therefore, to undo adding, I'm going to subtract the 5 to both sides. Now you can see I have a negative x equals 6. Now again, ladies and gentlemen, we're not trying to solve for negative x. We're trying to solve for x. So you can see that that negative, I need to get rid of that negative. Basically, what I have here is a negative 1 being multiplied by my x. That's basically what negative x means, negative 1 times x. So I need to undo multiplying by negative 1. So to do that, I'm going to simply divide by negative 1. By doing that, I now obtain x equals negative 6. All right, to the next one with some fractions, right? All right, finally good. Now, the cool thing about doing a problem, at least with the fractions here, is we don't really need to worry about our fractions yet. We see that my variable, here's my variable x I'm solving for. It's being divided by 4, and it's being added by 2, right? Well, again, first thing, what do we always undo? We always undo addition and subtraction first. So I'm not even going to worry about my fraction right now. I am just going to undo adding 2, which will tell me to subtract 2. So therefore, I have x divided by 4 equals, if you owe me $6 and you borrow $2 more from me, you now owe me $8. OK, so now this one is the one that students always forget and they always get trouble with. Remember, if you're multiplying to undo multiplication, you divide. To undo addition, you subtract. To undo subtraction, you add. So to undo division, you have to multiply. So to undo dividing by 4, I'm going to multiply by 4. And a lot of times when you're multiplying by 4, I just write it as a 1 just so you can know that the 4 is in the numerator. I don't need to write these both over 1 because they're both whole numbers. Anyways, that leaves us now with our final answer of x equals negative 32. OK. Over to the problems. Here I have 1/4 x minus 3 equals a negative 5. So basically what we're going to be doing with this one is, again, actually, it's the exact same thing. Now you can see my variable is being subtracted by 3, and it's being multiplied by 1/4. It's being multiplied by 1/4 instead of being divided. OK, cool. So anyways, we need to undo addition and subtraction first, right? It's being subtracted by 3, so I undo subtraction by adding a 3 to both sides using the properties of equality. Therefore, now I'm left with 1/4 x equals negative 2. Now, over here, you can see that my variable is being divided by 4. And it was kind of basic, right? You just undo division. Here, you can see it's actually being multiplied by a fraction. These are actually the exact same thing. Exact same thing, just written differently. You can still just multiply by 4 on both sides. Or basically, what I always like to tell people is whenever you have a fraction in front of your variable, multiply by the reciprocal, which means flip your numerator and denominator, and multiply it by on both sides. OK? It's the exact same thing. You're still multiplying by 4 like I did over there. It's just a different way of looking at it. Any number multiplied by its reciprocal is equal to 1. So I'm just left with x. Some students get confused here because here I just multiplied by 4. Now I'm multiplying by 4 over 1. Well, again, really, guys, negative 2 is really negative 2 over 1. So when you multiply fractions, you just multiply straight across. Negative 2 times 4. And 1 times 1 is negative 8 over 1, which is just negative 8. I should have wrote that in red, but that's OK. Actually, let's just write it in red. I've been writing all my multiplication ones in red, so there we go. OK. So now again in here, in this example, we have, again, we're doing another one of these where I have my x to the right. So again, until you get used to this, rearrange them. So by rearranging this, I have 2x minus 5 equals 19. Now it's much easier to see, oh, I'm subtracting 5. So to undo subtraction by 5, you're going to add a 5 to both sides. Therefore, you're left with 2x equals 24. Now, to undo multiplying by 2, you're going to divide by 2. And then your final answer is x equals 12. Now, what video would not be complete unless I completed one with fractions, right? So I love this problem just because it just gives so many kids so many fits. And they're like, oh, my God, how do I even do this? Well, back in the day, you learned how to add fractions to whole numbers, add fractions, multiply by fraction, divide by fractions, and so forth. And I would say that'd be coming very handy in a problem like this. And you could definitely do that. However, the one thing I tell my students is, you know, our main thing, especially in Algebra 1, Algebra 2, pre-calculus, so on and so forth, is to get rid of fractions. We don't want to deal with fractions. Even though we should know how to use them, or we could even use a calculator, we don't want to do operations with fractions. It just brings in more trouble. So what I tell my students to do is get rid of the fractions. Now, you can only get rid of the fractions by knowing what all the denominators are and multiplying everything by the least common denominator. So I'm rewriting negative 1 as negative 1 over 1. So you can see my my denominators are 4, 3, and 1. So I need to find a common denominator that 4, 3, and 1 all divide into. And that is what we call our least common denominator. And our least common denominator, in this case, is 12. So what I'm going to do is I'm going to multiply everything by 12. So it's going to be 12 times x over 4 minus 2/3 times 12 equals negative 1 over 1 times 12. OK, now let's look at what happens. 12 times x divided by 4. I can divide 4 into 12, which gives me 3x. You could multiply this across if you wanted to. 2 times 12 is 24. Divided by 3 is 8. And then 12 times negative 1 is negative 12. Divided by 1 is just negative 12. OK, so now you can see now I have it in a two-step equation, right? So if I multiply my least common denominator, I have now created an equation that is that does not have any more fractions. So now we just follow our exact same steps we've done before. If I have subtracting my variable, I'm subtracting my 8, so I'm going to have to add 8. And I add 8 to both sides. Therefore, I have 3x equals, that becomes a negative 4. Then, to undo multiplication by 3, I need to divide by 3. And my final answer is going to be a fraction, which is perfectly fine. X equals a negative 4/3. So there you go, ladies and gentlemen. That is how you solve two-step equations, especially one with some fractions. Thanks. Ugh.